Hey everyone, and welcome. You know that feeling when you look at a coding problem and then you see the solution and you're just left scratching your head wondering how in the world did they get from point A to point B? Well, today, that's exactly what we're going to do. We're pulling back the curtain on a Python tutorial, breaking down the solutions to show you the logic step by step. Let's start bridging that gap between the question and the answer.
So here it is, side by side. On the left, you've got the challenge, right? The list of questions. And over on the right, the finished code, the answer key. Our entire goal here is to build that bridge, to get from the problem over to the solution, and really understand the why behind every single line of code.
All right, first up, we're jumping into one of Python's most powerful features, the ability to slice and dice lists. All this means is grabbing the exact pieces of data you need from a bigger collection. You know, in Python, we call that a list. It's basically just an ordered collection of, well, stuff.
Okay, let's ease into it with the basics. So the very first task, just display a name. The tool for the job is the print function. It's literally Python's way of saying, hey, show this on the screen. Anything you stick inside those parentheses and quotes, boom, it gets displayed. Simple, direct, and it just works.
Okay, now before we dive into the really tricky stuff, we've got to lock in one absolutely critical concept, the list index. Just think of it like a street address for every single item in a list. But, and this is the big one, the thing you have to remember, Python starts counting from 0. It's a zero-index language. That means the first item is at position 0, the second is at 1, and so on. Seriously, getting this down is the key to, well, everything that comes next.
So let's actually see this in action. To spell out hello world, we're just going to call up the right addresses from our alphabet list. So alphabet 7, that gives us our H. Alphabet 4 gets us the E. For the double L, we just grab alphabet 11, which is L, and multiply it by 2. Pretty neat, right? And then check out this last part, negative indexing. This counts from the end of the list backwards, so -4 is a super slick way to grab that W. It's a really handy shortcut to know.
Okay, so the warm-up is officially over. We figured out how to grab single letters. But the next challenge, it's more like a puzzle. We're given this big, long jumble of characters, and our mission is to pull 4 specific words out of it. And yeah, just grabbing one letter at a time isn't going to cut it anymore. We need a more powerful tool.
And that tool, my friends, is called list slicing. The full-on syntax looks like this: start, stop, step. It's pretty straightforward. You tell Python where to start grabbing items, where to stop, and here's a super important detail. It goes up to but doesn't include that stop number. And finally, the step tells it how many items to skip. This gives us like surgical precision to pull out exactly what we want. Let's try it. For our first word, macro, the solution is word 1 to 6. So what's that telling Python? It's saying, hey, start at index 1 and grab everything up to but not including index 6. And just like that, boom, we've pulled our first word right out of that list.
Okay, now things get really interesting. To find the word poor, the code is word 7.3-1. See that -1 in the step position? That is a total game changer. It literally tells Python to read the list backwards, starting from index 7 and going down to index 3. I mean, how clever is that?
So what about the word fail? The letters aren't even next to each other in the list. So how do we handle that? Well, the solution is to use that step value again, this time with a 2. So word 14.22.2 means start at index 14, go until 22, but only grab every second letter along the way. It lets us just leapfrog right over the characters we don't need.
And this last one, oh, this is such a brilliant Python shortcut, a real pro tip. To find the word economics, the code is just word/series3. By leaving the start and stop positions totally blank, we're basically telling Python, hey, look at the entire list, and that 3 just says, and pick out every third letter from start to finish. And this isn't just for puzzles, by the way. In the world of data science, this is a super common and efficient way to grab a sample from a massive data set.
Okay, so we've pretty much mastered pulling data out of lists. That's awesome. So for section B, we're going to level up. We're going to give our code a brain. It's time to teach our programs how to make decisions using something called conditional logic. And the 3 key tools for this are if, elif, which is just shorthand for else if, and else. The best way to think about it is like a fork in the road. The if statement asks the first question. If the answer is yes, we go down one path. If it's no, Python checks the elif for another question. And if none of those conditions are met, the else block is our default path. It's what happens if all else fails.
So the big question is, when to use which? Well, the first couple of problems in this section make it super clear. If you've got a simple yes or no question, like, is this number 1 or greater? Then a simple if-else combo is perfect. But if you've got multiple possibilities to check, like, is the number greater than 1, equal to 1, or less than 1, well, that's when you need elif to handle those extra cases.
Okay, let's look at that first example right now. The code checks if x greater than equal to 1. If that statement is true, it prints one message. If it's false, the else block just automatically kicks in and it prints the other message. See? It's a clean, two-way street.
But now let's look at the second problem. This one needs a bit more nuance. First, we check if x is greater than 1. If that's not true, we then use elif x equals 1 to check for that one specific case. And only if both of those first two checks fail does the else block finally run. This whole structure is what lets us handle 3 totally different outcomes. Easy.
All right, and now for our final puzzle of this tutorial. It sounds simple. We have 2 numbers and we just need to find the difference between them. But here's the catch. The result has to always be a positive number. It doesn't matter which number is bigger to start with. So how do you write the code for that?
And the solution is actually pretty elegant. All it takes is a simple if statement. First, the code checks if the first number is bigger than the second. If it is, great, we subtract the second from the first. But if that's not true, the else block kicks in and we just flip the subtraction around. It's a simple trick that guarantees we are always subtracting the smaller number from the larger one. And that's how you get a positive result every time.
Okay, let's take a quick step back and just think about what we've covered here. We've just walked through some of the most powerful, most fundamental building blocks in all of programming.
Let's just boil it all down to the 2 huge concepts we've really unlocked today. First, you've got list slicing. That gives you the power to target and pull out data with amazing precision. And second, there's conditional logic. That's your if, elif, and else, which gives your code the ability to react, to evaluate, and to make smart decisions. And please remember, these are not just clever little tricks. This is the bedrock. This is the foundation that almost all complex software is built on.
So yeah, we've seen how these tools can solve some fun little puzzles. But their real power, their true purpose, is in automation. Slicing data and making decisions. That's the heart and soul of everything from automatically sorting your emails to analyzing massive amounts of scientific data. So that really leaves just one question for you. Now that you have these building blocks, what's the first simple, maybe even annoying, task in your life that you'd want to automate with them?